Phase 2 of the project.
Right. All right, folks, let's get started on the introduction. Those who don't know me, I am Mohammed Gader. I'm the organizer, and I have a co-organizer, Amit Agarwal. So we both resonate, and there are a few resonators. Raise up your hand if you're working for Resonate. Okay, all right. Whole bunch of people. All right, so we are so excited to host our first meetup in AWS and machine learning, and welcome and feel at home. And so it's going to be a great presentation. And there's one change in the presentation today is we don't have the Jupyter presentation because Kirk got sick, and so he couldn't make it today. So probably we will have it in the future session someday. And with that, I'm going to introduce our VP of Engineering, and Pedro. So he wants to say a few words about Resonate.
So thank you, Mohammed. Again, you guys welcome to our headquarters here in Reston. This is our first in a series of meetups that we're trying to host. We're shooting for something on a quarterly basis, and the theme centered around AWS and machine learning and everything in between. And so again, I'm Pedro Brada, VP of Engineering.
Which is not going to make the problem better.
All right, so hopefully that might get sorted out. But I want to tell you briefly about Resonate. And so we're essentially a consumer intelligence platform. And what that means these days is that we're trying to help companies out there understand why their customers behave the way they do. And hopefully, through that understanding, we can help them make, better marketing decisions, better, decisions about how to iterate their products, or better decisions as to, what product to build next. And so, to develop this understanding, right, is where, we leverage a lot of, AWS. About 80% of our infrastructure runs AWS. And we have all kinds of technologies in the mix, and machine learning being a key component of it, right? So. We essentially try to be able to describe the U.S. online adult population, right, and be able to say 10,000 different things about them, right? People are male, who are the people who value environmental protections, are Donald Trump supporters, and so forth, right? And so through that, combining, collating all that information together into a single platform, right, so that people can answer these business questions, right? That's essentially what we do, right? And so, welcome again. I'll hand it back to Mohammed, who will introduce the host. But you've seen, maybe raise your hand again, Resonators, right? Please feel free to reach out to them if you want to know more about Resonate, and visit resonate.com, and we'll be happy to answer questions for you at the end of the meeting today.
Right. Thanks, Pedro. And there's another persons. Jenny and James, they are the admin, and they are the one who made this whole thing happen, and thank you. So with that, I'm going to hand over back to Doug for our first speaker.
Alrighty, I'm Doug Toppin, as you can see up here. So I've been using AWS for quite some time, and I started using the XRay service some months ago, about 6 months ago, something along that line. And I've been extremely impressed with it. It's one of those things that I found a lot of value for right away, and I was shocked how quickly it was useful. And then what I found was that after a couple of weeks, I thought, maybe I better check on what it's costing, and it hadn't cost anything. I thought, well, that's kind of amazing. Then I checked after a month, it had 2 cents a day, something like that. So what I found with XRay is that it's one of those services that you can get a lot of value of, that's really useful, particularly when you need it. And it can cost extremely, just a tiny amount, and you can control those costs. So there's a variety of aspects of it that I like so much that I started putting this presentation together just to show some of my experiences. Now, code-wise, I'm only going to show some code in here because there's not a lot of code involved in using XRay. The important thing is to recognize the value in it and what you can get from it, and my experiences hopefully are going to be useful to you. So what I wanted to talk about tonight was, first, what is it? What is XRay itself? And I know a few of you are using it. Why you might want to use it. What's it cost? I've already said you may be kind of shocked how little it can cost, but like everything else in AWS, it can cost little or it can cost a lot. Amazon gives you all the tools that you need to control your costs, to keep them at the minimal possible level, but they leave it up to you to use them. They'll let you run a service open loop and spend a fortune if you want. But you can avoid that. So, and XRay, I think, is an example of that. How does XRay work? What's involved in it? What does it actually do? What's it composed of? And my specific situations where it helped me, and these are the ones that I think that I have found most useful, or as examples, I guess, of it. How did I use it? Where did I make use of it in the systems that I'm responsible for? The demo is nothing other than screenshots of the XRay console and a little bit of code. Because again, the code is not complicated by any means. It's the concepts that are most important and the recognition of what you can get from the service itself and make use of it. And then lessons learned, meaning the things about it that I wish were different, any issues that I had, links to useful information. So that's what we're going to hit on tonight. So generally I start these with just exactly what Amazon says is the documentation for the page for the service itself. So all this says basically is, it says debug. What you're really doing, I think, is it's increasing your awareness. I wouldn't necessarily call it debugging. It's your awareness of what's going on in your code, in your system, and you may use that for debugging, or you may just use it for general useful type stuff, and then you'll see some examples of that. So I think that some aspect of it is how your application is working and some of the underlying services, meaning there are some things that you're going to get more information out of XRay. And you may learn some things about other services in the use of XRay. That's been one of my experiences as well. I picked up some Lambda information that I hadn't realized before. It can provide an end-to-end view of requests, meaning it can trace throughout your entire request chain, basically. It's surprising how much information is sitting there. It's particularly useful if you start looking at the headers that are being passed around, because it's enriching requests to some degree with header information. So there's metadata sitting out there you may not know is there. That's why sometimes it's useful in your Lambdas to, when the Lambda fires up, print its environment or log its environment, because sometimes it's interesting to see what you're finding in the environment, particularly in requests coming in, for example. Seeing a map of the stuff that your application is using can be very interesting, and I've got an interesting experience of that I'll talk about as well. So lastly, it says analyze applications in development and production. This is one of the things I'm particularly keen on. I believe your logging, everything that you do in production, you should do in the same manner in non-prod environments, meaning developers should get used to the way logging works in non-prod and use it for their own troubleshooting, conceivably down to the unit test level, so that they will tend to create dashboards, learn how to log, etc. in ways that convey on into production. So something that I have seen in the past was, this is tangential, was that if you use serious logging systems in your production environment, but the developers don't use them for debugging, they're not going to tailor their stuff or to accommodate that, and that can be kind of a pain. I'm a big believer in the fact that when they're creating dashboards at the unit level, at the development level, those dashboards should convey all the way down into production, whether it's CloudWatch or Splunk or whatever it is that you're doing. So anyway, let's keep on going. I get on that subject, it's hard to get off of it. So the key thing about XRay is that you can collect application performance metrics, and what I mean by that is how long it took to do something. Now that something is kind of up to you as to what level you're going to control of it, meaning are you going to metric or create traces or log data or capture data when you start something and when you finish it, or just when the request starts and the process exits or returns or whatever it is, or are you going to do it at much more granular levels? And I've got some examples of that in some of the XRay screens that are sitting, screenshots that you're going to see. This, by far and away, is one of the things, that's hard to do, here. Comparison. So it's like anything else. A metric doesn't mean a whole lot unless it's 0 or a bazillion and you don't expect it to be. Where metric values come from are the comparison over time or across events or something along that line. And that's the area that I've seen the biggest amount of value in this, is that when you make a new deployment and suddenly something starts slowing down, or you start getting slower responses or faster for that matter, and you wonder, what's different? Well, the request is faster. Why is it faster? So XRay can give you a lot of information about why it is faster if you thought about that in advance of how you want to capture that data. but it's that idea of comparisons across a period of time, whether it's across deployments or the fact that the outside world is affecting you. Outside interfaces that you're using, they may slow down, they may speed up, whatever it is. There may be other information sitting out there. So again, these are the things that I have found particularly valuable. By the way, I tend to do Meetup type presentations with the opinion that it's a live wiki, meaning I guarantee you some of you out there know more about this or other things than I do. There's no doubt about it. Please chime in to say that. Pass along what you know, your experiences, and watch out, it's coming down. So treat this as a situation for you to chime in and add to what I'm saying, or say I'm wrong, or do whatever it is, because your experiences are equally as valuable as mine. So if you know about X-ray or anything related to that you want to pass something along, please say so, because I guarantee I'm not the sole source of information for this. Again, treat it as like a live wiki. I like that idea of comparison, and that's where you'll see some of the screenshots that are useful for me, or situations that have been useful for me. I keep yakking about cost effective. The reason for that is when I was consulting previously, in every AWS or every client that was using AWS, every single time, eventually somebody said, all right, AWS bill's getting too high, we need to switch to Azure, or whatever it is that they said. As opposed to trying to capture or recognize what those costs are in advance and control them early on, architect in a way that you're not burning up your budget unexpectedly down the line when you are locked in. And I hate to use that term locked in, because there's no such thing as lock-in, there's only a switching cost. But what I mean is that once you've invested a lot in something and later the costs grow out of proportion, it's at that point you start regretting what you did, as opposed to trying to capture them or early on control them and not waste your money. And this is something that Vern Vogel said at reInvent last year that really resonated with me. I won't forget. And it was only 4 words: don't pay for idle. If you're not using it, don't waste your money on it. Use that money for something more valuable: labor, bonuses, artwork, whatever it is you want to do. Don't just pay them to provide some function that you're not using for some value anyway. So again, I yak about that a lot. But X-ray is an example of one of those things that you can let its cost explode if you're generating a ton of traces and you're never looking at them, or only looking at them every now and then. You get the opportunity with X-ray to tune those down quite a bit. So this next thing is particularly key to me. If it saves you any labor, it's worth the money. Labor is the type of thing that it's really hard to capture the time that was spent doing something, because whoever was pursuing something, whatever it is, they're not doing something else, and they are off track. It's a mental context switch. It's hard to get back to what they were doing, and so on. So if you have data, if X-ray provides you anything that saves you any labor, it is worth the money. I guarantee that, because you never get back time. You never get back labor. You can only go back to the pot and ask for money, but you can't get time that's passed on the calendar. So anyway, lastly, what I was saying about cost control, you can dial up the amount you're collecting and doing stuff with, dial it right back down again, depending on the situation. So what does it cost? This is right out of the AWS page, or their pricing page. And notice that first thing, the first 100,000 traces that it's doing per month are free. This is the reason why you can end up with a zero bill. You can use X-ray to a significant amount of value and not pay anything for it. Or when you start looking at the data, when you start looking at those requests, then it can cost you some, depending on what it is that you're doing. But again, it all depends on how you're using this. That X-ray data can also be exported. You can actually capture it externally and send it to something else if you want for other processing. So key thing on this, as they show right down here with this thing at the bottom, in this case with 48,000 traces, they spent 24 cents. My experience has been literally, it's been anywhere from 0 to the most expensive day that I had was 6 cents one day, and I was wondering if I should go look and see why that was, which sounds funny to say that, but I have a vivid memory of that, where I was looking at day in the cost explorer, and I saw 0, 0, 2, 0, 3, 5, 6, and I thought, whoa, why do we go to 6 cents? And it's funny to say that, but it's like one of those things that, it's an anomaly. So anyway, so what I have are a couple of examples that I use. One was a Python Flask application, and then Python Lambda, which just 2 different usages of it. So the majority of what I've done for the last year or so has been Python and Fargate. If you're not using Fargate, you should be. That's That's my opinion. I have found for the first time in my life, I spent a little over a year and not maintained one server. Everything I've done has been Lambda, Step, or Fargate. Not having to do it, everything associated with provisioning, maintaining, bouncing, backing up, etc., EC2 instances, not having had to do that for a year, I'm particularly impressed with that. It's been a very good experience. I have zero complaints about Fargate. No question about it. So anyway, I fiddled around with Lambda. I've got a simple Lambda that I can forward email to that'll extract some information and do some stuff with it. That was some of the screenshot examples we're going to see on this. So again, I'm not necessarily showing any code as much other than the AWS page to show it, but it's the key thing of understanding what you can do with some of these deals. The other thing people may not realize is you can use XRay outside of AWS, meaning it's just an agent or it's just collecting information that's forwarding on to the service. So you can run it on your own machine if you want and collect information. You can do non-AWS resources just fine with it. I've done that one time just to prove that I could do it, but I haven't needed to do it since. The AWS or the XRay agent is what is fundamental to that, basically. So, or for that matter, if you really got no life, you can actually have your application forward XRay the data itself if you really get into it at that level. So what does XRay, or how does XRay actually do stuff? It's composed in 4 phases of stuff, or segments, or whatever you want to call it. The first one is collecting information, meaning on the left side, or next to the left side here, collecting traces just means capturing metadata with events. Something started, something finished. In the end, that's really all that it is something started, something finished. Timestamp, annotations, metadata associated with it can be captured. That's what gets collected and sent on by the agent to something else. Those traces, that data that's being collected gets sent somewhere else with some sort of information to match it up, because you could have a crap load of things generating XRay data, and distinguishing what's doing what becomes important later, and naming gets really important. And I don't have a screenshot of this, but I'll talk about it when we get to it. Then view service map just means going to the XRay console and looking to see what data do I have. This is the area that I've had the chief, well, probably not, analyze or view service match to some degree. This will be my chief complaint about XRay, is that I don't find it easy to do anything other than look at the last 6 hours. I always have a hard time going back to some previous day and looking at particular time periods. So anyway, and that's on my wish list for them. We'll talk a bit about that a bit more later. And lastly, analyze. They have an analytics link on it right now that lets you do more comparisons, deep stuff. I have a hard time with that analytics thing, I swear. I still can't use that word with dirt. So where did it help me? This was the thing that I thought was particularly funny. I don't think I've ever had this happen before in anything that I've been doing software-wise. And that was, I stumbled on XRay. I read about it from some source. I can't think what it was. I thought, this sounds kind of interesting. I said, let's stick this in. I was talking to my team. I said, let's stick XRay in. They said, oh, okay, whatever you want to do. So we stuck it in there. And 2 days later, literally, something happened, and we were wondering what the difference was. What was different between that day and the day before? And I thought, well, heck, I'll go look at the XRay console. Bam! It jumped out at me immediately what had changed. Had that not been there, I could have done it otherwise. I could have gone to Elasticsearch. I could have looked at our logging. I could have narrowed down. I could have compared log messages, and the application I'm talking about generates 700 messages for every single frequent request it does. I could have done all this stuff, which would have been labor intensive, would have taken time to do it. I would have gotten tired of it, gotten distracted, gone done something else almost for certain. Or just go to the XRay console and bam, I saw immediately what the cause was. So we'll talk a bit about that more. In this case, it was the fact that some S3 activity or responsiveness to S3 had changed because of a code change outside of the system I'm involved with. The other thing was there were several other occasions, and now it's more than 3, where something changed, or behavior of one sort or another changed, and XRay told me really quickly where that change was and gave me a way to point the finger really fast, as opposed to standing there saying, hey, something's slower than it used to be, type thing. And being able to evaluate a code change and quickly say, hey, this change made it a lot better because now we're using sessions, for example, in Bodo. So where, as I said earlier, where I was using this was as follows. This is both working at home, and that is Flask apps running in Fargate. Those Flask apps did S3, Dynamo, and some SNS SQS type activities. All those things are useful to metricize, to know how long something particularly took. Particularly if you're in West for a while, for example, and your latency is a little bit longer when you do an assume roll. It's interesting to see the difference between East and West, stuff like that. Those are all useful tidbits that are worthwhile to capture. By the way, these slides are all on a PDF. That is in the last page of it. You'll see the link to it, so I should point it out. And then Lambda, which was just doing some S3 and SES type stuff. That was the thing I was talking about, my little email processor guide. That does a couple of external calls. It's useful to see that type of information captured. Again, these are things you could do with logging. You can go look at CloudWatch, you can see the logging, or you can see it in that common term, one pane of glass. So we're going to talk about screenshots now. The first time you use XRay, this is probably what you're going to see, something along this line. This is the XRay system map. So on the XRay page, on the left-hand side, you're going to, or services map, that's what it's called. You go inside there and you're using XRay, you have some stuff that's being captured, you may see something along this line. This simply says, this is a Hello World application that did have XRay, was collecting XRay data. It did a couple of things. It went to S3 and it also went to a remote REST service. So what you see right here are the request chain, basically. That might be the best way to say it. Where this application went out and did something with S3, and then it did something with a metadata. Oh, no, that's right. This was a metadata call. It used the ECS metadata service. It wasn't external. Another one shows that. This is one of the first lessons learned that you'll encounter if you're using XRay. This was a Hello World S3 metadata call. Let's say you got 1,000 applications running. It's a good idea not to have them all have the name Hello World, basically. It becomes important to name your traces or name your segments in ways that either one, identify the environment they're coming from, the cluster they're coming from, the application they're coming from. And this is one of the things I've been particularly keen on with the things that I do with CloudFormation. And that is when I'm creating resources, whatever they are, clusters or applications, I always concatenate aspects of the name that indicate the region it's coming from, the service it's coming from, the cluster it's coming from. The idea being you should be able to create your resources in parallel to each other and have silos, for lack of a better term, that lets you use all these CloudFormation to create this environment, create another environment and call it Fred or Dev or whatever that you want, another, and then blow those away. Don't use hard names in any resources that you create that prevent you from creating multiple ones in parallel unless they really are global to the account. So anyway, XRay is exactly the same way. Because when you go to this console, if you got 200 or if you got 100 Lambdas, which may not be unusual at all, and all of them are collecting XRay data, it can be pretty difficult to figure out what it is that you're looking at. And why I say that, I just had that experience probably a couple of weeks ago, and that was we had all of our Lambdas, or a number of different Lambdas that were triggering off an S3 event. And it was the first time that I had seen all of them fire at once. And all of a sudden, my XRay page had 100 different segments on it. It was surprising because, and it wouldn't typically have been that way. It was just an unusual occurrence that did it. So that's why that naming can be so important. So again, if anybody has comments on how you're using XRay, how you've seen good and bads, etc., chime in and point out anything that you find helpful as well. So let's go a little bit further. If you take this screen and you click on something like this guy right here, for example, you'll probably get to something like this. This is the next level. This is saying, for that segment, I want to see the traces that show up. Now, sometimes you may see a URL here, and sometimes you won't, depending on what it is that you're doing. So, for example, you might not see it in a Fargate worker who's not a REST interface. So, this potentially will be different depending on what you're doing. You can control this name, but my point being, this is one segment that's occurring, and then here are the traces that came out of that segment. Traces being events that were specifically metricized, or whatever the right term is. So these are two different requests that came off of a Fargate worker, if I remember right in this case. So in this, what you'll see are, one, you can group these things in different ways. This thing that says group URL, You can see return code, exit code, or 2 or 3 other things. There's several different things in that let you filter this area some. You can also, up here, have it specifically look for services, for example, that if you want. So what you're likely to see in a busy environment is a whole lot of segment data. Narrowing that down to what you care about makes it a lot easier to more quickly see what's going on. You can also curate groups of applications or groups of services in here that let you filter as well. But those can have a cost to them. They're not necessarily always free, the grouping of them. So anyway, up here, this is saying, show me what was going on for the last 15 minutes. Or it might say 5 minutes, or it might say up to 6 hours, or whatever the defaults are. I forget that in there. This has been one of the areas that I have found that I have seen as being difficult with XRay, is that I don't know why they have it this way, but it's not easy to say, show me the last 24 hours. In fact, you can't say, show me the last 24 hours. So instead, what you have to do are using up to 6 hour periods at some start time in UTC, or else a relative time only. I find that hard to use, and I generally, anytime I want to see what happened yesterday at 3 o'clock, I have to sit there for a while and think about what 3 o'clock is in Greenwich time. And I'm surprised sometimes how I will be in the wrong direction, and I will be looking in the morning instead of the afternoon and miss it entirely. So anyway, that's one of the funny things that I have found about it, and I comment on this later as being a wish list type item. The traces down here, you click on one of these guys, and it will take you to the next level that will show you the request activity, or the activity that occurred when that request was being processed. Notice in here, age, how long ago this trace was collected. Over here, how long it took for that request to occur end to end. Those can be useful things. And sometimes you'll see some other stuff in here that can be useful with annotations and otherwise. And that's one of the lessons learned or tips I've got on these things. Let's go a little bit further in here. So if you pick one of those traces, this is what you're going to see, or something like this. So what this is saying, I just picked one trace, which is one request that's going on. What you see up here is how long did it take start to finish, how long ago was it, when did it happen. Down here, this is what actually happened. Now in this case, this is that first situation where I said I had a Fargate task that went out, and no, this was the flash task that went out and got some metadata. Anyway, this went out, got some stuff from S3, and then it went and got some metadata. Over here on the right, how long each of these events occurred. This first thing up here is that idea of a segment, meaning when a request starts, or some portion of your code, you can call a segment, and then everything under that can be subsegments, and those subsegments can have names individually. So, for example, if you only cared about start and finish, or the time that took in between, that might be all you have. But you very likely are doing something inside your code that you're going to care about seeing start and finish, or duration. Example is if you're calling some serious compute, or you're going to SQS or S3 or other things for that matter. Being able to uniquely identify those and see how long they took is useful, and that's what you're seeing over here on the right. So for example, in one of the applications that I worked on, we had some compute time that was a Fargate task that was running 17 minutes worth of compute time, which is actually why it wasn't in Lambda. We just had a tidbit. It's useful to call those things out specifically. In other words, have that be a subsegment. When you call some intense compute function, do an XRay subsegment, a subsegment before it, and when you get back from it, if nothing else, just so you can see it and see if it changes over time. So external things like S3, obviously, you're going to care about. Particularly, you may see changes occur over time. You may see changes occur in different regions, or depending on whether you're doing an assumed role, for example, and that's very true with S3. You could see 150, 200 milliseconds added to a request, and it's useful to compare them over time. On the right-hand side is a visual, a graphic that shows basically this, except it shows you what the end-to-end time was and then what the subsegments are sitting down here. It's just a kind of a quick way to look at it and see and recognize where you're spending a lot of time in your code, or in the simple case, it doesn't necessarily look that much. But in a bigger case, you can see quite a bit of you can glance at it and see a fair amount of information without having to look at the numbers. Let's go a bit further. So, let's say you did a deployment something changed, and first off, you can see this. Something's different in one of the subsegments. This time it's got a graphic in there saying, hey, something failed. That can be useful. These are things you can see within logging, obviously, or some other means, but this is a quick way with eyeballing it to glance and see something's wrong, something's different anyway than what it used to be. How long did the request take? Notice this took 25 milliseconds and it also resulted in a fail. A mouse over on top of that will give you more information about what that fail was, and sometimes it'll give you quite a bit more information. I think this next screenshot may show what that is. But this is that idea where that previous page and this page is across a deployment. Comparing those two together can be very useful. Let's go a bit further. So, mouse over on that icon. Fault caused by file not found, no such file or directory. This was an example of the simple Fargate task or whatever it was that I had to try to open a file that didn't exist, just to show this is what it looks like, this is what you can see on that page. Now, this gives you a quick piece of information that you could have gotten otherwise. Again, you could have gone to logging, you could have looked around, you could have looked, searched for request ID, gone to that specific request ID, found it, or you could just go to XRay and see it. Some of this is being helped by Bodo being there. Some is being done just as a part of XRay itself. So, by the way, again, don't hesitate to ask questions because I tend to talk fast sometimes, and I may shoot by something that you care about. Right? Let's go a little bit further. So, if you pick that subsegment and you look at some of the specifics of it, you're going to see some tabs that pop up. This was that subsegment called Get File. There's a number of tabs here. One is the overview. That overview tells you start, finish time, how long it took, whether it's still in progress or not, any errors or faults that occurred. Notice there was a fault, there was a true under a fault. So this is sort of the top level information about that segment. This is also where you get an opportunity, I think, of doing some more stuff. Some of these other tabs, such as annotations and metadata, you can insert or add data yourself if you want in these areas. A really good example is request ID. You start processing a request, there's probably a unique identifier for that request, a UID or whatever. You could add that to your XRay subsegment as metadata or annotation or whatever it is. And it makes it easier to look in here and trace that all the way back to something specific or a specific request that got processed, and then go back into your logging system and look at it to get more information from that. Right? Annotations. In this case, I had added a manual annotation. I had the application that was trying to open a file was going to fail. I had it actually specifically log. What was the file name? It's one of those things that you never can tell when it will be useful to know that. So I was just trying to show here that you can add information to trace data that wouldn't be there otherwise. Metadata. You can add data on top of that as well. This can be more complex. Annotations are probably simple key value type things. But with metadata, you can put some more information in here and have it be a bit more complex. That's being captured. One of the nice things about XRay, again, is that's sitting there for a while without you having to do anything. That's one of the things I particularly like about it. XRay data isn't kept forever, but it is kept for a period of time that can be particularly useful. I kind of associate this with, or an analogy to this, are step functions. I mean, that step function execution data sitting there for X weeks or months is really useful when you're going back to look and see what it is that happened within something. Exceptions. That's captured as well. Again, these are all things that are in your logging system almost certainly, but you can more quickly go to XRay and see what it was. In this case, it was a file open for something that didn't, or an open file attempt on something that didn't exist. Okay? Yep.
Can you integrate this with the CloudWatch? Alarms notifications?
Well, it's that you can't put alarms into here, and this is being, well, your logging is probably sending this to CloudWatch anyway, so I kind of see it as
Just as
parallel, like, rather than necessarily in CloudWatch itself. I'm assuming that some of this you're logging anyway. So yes, I wouldn't say they're integrated as much as they're complementary. Maybe that's better, or supplementary, or something like that. Whatever the right term is. Yep.
Is XRay able to trace non-HTTP requests, or is it?
Absolutely. Oh yes, certainly.
Okay.
Yep. So XRay is available for a number of different, well, at least several different SDKs anyway. Python is what I've been doing for quite some time now, so it's Bodo. That's all I know about nowadays. In fact, I haven't even used XRay with Node, now that I think about it, now that you mention that. So One of the nice things about the supported libraries is that when you enable XRay and you do, in the case of Python, what's called a patch all, it goes out and adds instrumentation to those known libraries to everything. As far as I know, everything input. I'm not sure it's everything, but it's everything I've ever used in any way. So the answer to your question is yes, outside HTTP, absolutely. This will show more than just that.
So,
Sure.
you said like a request, let's say UID, right? And let's say there is no response. Request was successful. Something is the call for some service is successful, but how does it trace back a response to the same UID?
Okay, actually, if you look at the headers that are being passed around inside this, they get assigned and actually convey through it the request chain, excuse me, itself. So the header, there will probably be a header that has the UUID in it if, for example, it came from an ALB. So if you create your own request ID, you can add it to the metadata and have it do it. You can also add it to the header so it gets passed along. I have not had to do that because every time I've needed to do something, I've been able to follow the request chain itself, particularly if it comes from an ALB, for example, and that's going to be what I'm most familiar with. So I have to think about, that's interesting, if outside stimulus like SQS or SNS, I'm not sure how that would work, but I think it's there. I'm not going to guarantee that because I thought I saw that XRay was now supported in SQS as well automatically, which means those headers are going to be, or that metadata is going to be passed along with it as well. But I haven't seen an example of that yet. I only read about it.
So how does XRay know specific exception versus log? How do they differ?
Well, it doesn't know the difference. I'm saying that if you were logging, you would have logged the exception almost certainly.
Okay.
This is, again, in parallel. I would treat the two things as complementary, or whatever the best term to describe that is. So it would not know that you were logging this. It was simply capturing this. It was capturing the result of the request, or the exception, or whatever. So this would have been there whether I would have been logging it or not, in fact. So, get a little more complex, and I think this is a Lambda, right? Yes. So this is an example of a Lambda trace. Man. Wow, look at that. So this is the same idea of a Lambda that was triggered. It is my filter email thing. I've got a Lambda called Kindle Filter Email. It goes out, does something in S3, goes to another S3 bucket, actually does the third bucket, that's right, and then lastly goes to SES. So this is the idea of seeing that request chain. So one thing that had several other things involved without me necessarily having to do much at all to do that. This can get really complicated. You can have very involved systems that show a lot of this stuff. But it also is one of those things that if you see 100 little bubbles on this, 100 little circles, you might have a lot of microservices, or you might have one big old monolithic service. So the way you architect your system is going to affect some of these things as to how it's going to look on your screen, and how easy it is to narrow them down or figure out what it is that you're looking at. So here's another example. This is that Lambda earlier that shows a Lambda kicking in and doing some. This is a Lambda I have subscribed to an SES, to an email address. So this is telling you that Lambda Fire. Notice the things over here on the left that you might not have noted before. Dwell time, attempt 1, initialization, invocation. The next slide, or one of the next ones, is going to explain what those are, but it's useful little tidbits to be more aware of in your Lambdas, because you're probably familiar with Lambda cold starts or not cold starts. This kind of information, information about that is being captured in here without you having to do anything. And in fact, when you create a Lambda, or at any time, you can enable metrics or something like that. That's one of the choices when you do it. That's actually XRay. That's what it's talking about. So you'll get the top level stuff at least in it when you do that. Notice what you're seeing over here is initialization, invocation, and then the segment and subsegments as to what they were doing. This is a function that goes and gets some email, calls the URL extractor, copies a file to another bucket, does some more S3 stuff, and then calls SES. With each one of those things having the time that it took for those events to occur, start to finish. That is where you get that value of comparison, meaning is it different today than yesterday? What's different between yesterday and today? Did we do a deployment? Do we have some interface that's slower now than it used to be, or are we being hammered by some outside source that's causing unexpected activity? So it's just that idea of being able to compare stuff.
So
Over
does
here
it-
on the right, this is what I was saying about the graphic, giving you more overview in a quick, glanceable type fashion. Yeah.
Does it store time series of data? How do you compare from?
Oh, well, we'll see that in a minute, actually. I'll
Okay.
show you now. You can use the analytics page, or you can do what I do and just have 2 freaking panes with different things on there, because I still can't, and I got to handle the damn analytics page. So it's funny, I'll show you an example of that in a minute, where for some reason I just don't use it effectively. So you'll see a screenshot, I think you'll see a screenshot of a comparison side by side. Crap, I didn't put it in here. All right, oh, that's right, I did an X-ray presentation at work. So what I did was what you just described was, we had a deployment, I saw something slow down, I sat the 2 panes side by side each other and compared them side by side to do it. That is not the right way to do it, but it's the way that, it's like I've been using VI for a very long time, because that's what I learned in the beginning, and I still tend to use VI for that reason. Even in PyCharm, it's not unusual for me to use VI in the damn terminal window. So someday I'll get a handle on the analytics page and be able to do better comparisons. It is in there, it's just, I don't find it easy to use, it's just easier to have 2 panes that are, or 2 tabs with comparisons side by side. So the simple, easy way. Let's go a little bit further. So notice, I said earlier, I mentioned dwell time, invocation attempts, and invocations attempts was a new one for me, and we'll talk a bit about that. Dwell time, how long did it take for this request to make it to a Lambda? That was what dwell time is sitting in there. This is at the bottom of these, I have the page that this came from, by the way, to explain what they are. Invocation attempts. So let's say you have a Lambda that fails. It may try again. It may try again. How do you know that's happening? Do you have any way to tell that you've gotten into a Lambda retry state outside of this? You might be able to do it with logging, but I actually don't know good ways of knowing that other than XRay. And I'm sure there are other ways to do it, but it's the way that I've seen that's been kind of useful. Notice what he says right here, what the page says. On an asynchronous, Lambda retries functions twice, errors twice. That means it's 3 times that it'll try something. Events may wait in the queue for hours or days to be sent to the function. You can configure a DLQ, which is a good idea, by the way. It's just useful. I didn't know about this invocation attempts, and I'm hoping I have a screenshot of that in here. If not, it's on my... there we go, good. So, this was an error that I had when I was trying to do some of that email processing. Notice what it showed. Dwell time, that's how long it took to get to the function. And then attempt 1, attempt 2, attempt 3. These were 3 different failures. I'm not sure I would have known that was happening other than seeing a log message saying, hey, tried this, tried this, tried this. This shows it to you pretty quickly, so I find that particularly valuable. And then the pending stuff down here indicating that something had failed. So, have you all seen a way, I'm assuming some or all of you doing Lambda type stuff, have you seen ways of knowing this sort of thing is happening? Because I don't think I have. I don't think I've seen anything in CloudWatcher that indicates Lambda retries. So again, this is the more complicated one, or this is showing those 3 retries. Each one of these is one of the retries. Each one of these guys is the error that occurred. And what that says, picture in your mind, size limit. That's what it is. Right. I was, right. This was a Python function I was calling that's called URL extractor or something like that. Or I forget what it's called. It's some Amazon thing. Oh, it might have been comprehend. That has a size limit on it. I was sending it more than it expected, and it was failing it because of that. That's what was causing these retries. So anyway, this mouse over, being able to see this quickly, was a nice facility to be able to do that. So this is the analytics page, and this is the one that I'm sure it does great and far out things, but I have yet to use it effectively to save my life. So if you go to analytics, pick one of those traces or pick a time frame, you can go into here and zoom in, see activity like this, see more things, but I swear I still end up going down to the individual traces to find stuff. All right? So this is where I think the comparison you're asking, you would see this better than what I do. It also does those neat p-interval type things sitting in here. It shows you all kinds of useful things. Or I just look at the raw data sitting on the other thing. This is what a Lambda looks like with XRay in it. So again, what I said earlier, when you have a Lambda, you can enable it from the start, or you can turn it on after the fact to create metrics or something like that. I forget. Whatever it is, it will at least give you the top level Lambda information. If you want to do it inside the code yourself, what you would do in this case is, and this again is the Python specific, this is importing the XRay libraries, packages you're going to install. This guy right here, patch the Bodo libraries. There's an equivalent for the other ones as well, but again, this is what I know about. That means at this point, all the Bodo library calls are going to, I think all of them anyway, are going to start collecting metrics data. The actual Lambda function itself, all this does is get a couple of environment variables out, put something into S3, get something from S3. That's what these functions are right down here. This is saying begin a subsegment, call it put object. This is saying here's the response back from that. Finally, send subsegment. So here's one of the lessons learned, and we'll cover those in just a moment. And that is that if you start a segment or subsegment and it never ends, you may lose the trace data for that. It doesn't know that it's not ever going to get it again, so as far as I know, it just disappears off into nowhere. So it's a good idea in your exception handlers, terminate any or end any segments or subsegments that you've created. Okay? And I'm sure you can't see this very clearly, but you'll see it in the PDF if you're interested down the line. So, and again, this is simply saying make me a subsegment. Oh, this is right, this was an annotation. So this is showing me explicitly creating a subsegment and ending a subsegment. This is an annotation saying I'm going to have a segment or subsegment in this area. I want to call it getObject, and it's going to take care of everything necessary for me, both the start, the setup, and the end of it. Okay. Ah, that's what it was, active tracing. So on Lambda pages, click that checkbox, and that will enable XRay for at least the top level set of information from it. All right, now, this little application I was fiddling with, I did for the demo, I use the Fargate CLI. So I didn't actually know about the Fargate CLI until about a month ago. I've been doing everything in CloudFormation before that. The Fargate CLI is a really useful thing, and it's something that's gotten popular lately, I've noticed. And that is, if you have this application, when you run it and you say, in this case, run, it checks to see, is there a Docker file in the directory? If there is, son of a gun, it's going to do a Docker build. It's going to do a push. Then in the Fargate CLI's case, it's actually going to deploy it to a cluster. So the Fargate CLI is a useful thing to have, and that's what actually broke in this when I was fiddling around with the SDK or the CDK recently, and I never got back to figuring out what it was that broke my demo environment. But with the CLI, this is just a make file that I have that all it does is say run a task in Fargate, stop the task that's running, go out and get some info from that task. So, and I should have asked, are you all using Fargate, or is anybody familiar or interested? Yep. Have you been happy with it? Or any complaints, that's what I should say.
It's a little bit expensive.
It can be.
Yeah.
It depends on what it is that you're doing. This is one of the key things about Fargate, is that it's really important to control the auto-scaling on that. Scale tasks up, scale them back down again. Now, there's no way to invoke one starting from 0. So it's always having one of them running, and then an auto-scaling group attached to it that scales up. But there's an interesting thing that I have not tried yet, I saw in the last couple of months, where somebody actually has an Nginx container in the task, and he uses Nginx to trigger more rapid scaling than you're going to get from an auto-scaling group. So my experience was with an auto-scaling group on Fargate is that it can take a few minutes for it to realize it needs to scale, and then it scales up relatively quickly, meaning I can go from 1 to 10 in less than 50 seconds and 1 to 50 in less than 2 minutes, something on that line. So, but this goes back to that cross control I was saying, is that Fargate is really useful, but it's really important to scale those tasks back down again, because you're paying for them, obviously, as you know, as they're running, And the documentation on their pricing for Fargate is a little deceptive. It says this is only going to cost you 0.0007 cents for a task that runs 10 minutes a month or something on that line. Well, I'm interested in the Flask app. What does it take to run that guy 24/7? That's the price I care about. They don't actually show that price. But what I do tend to find is that reduction of operational labor, not having to maintain instances. So while there's a cost, and I'm off subject here, sorry, while there's a greater cost associated with Fargate, factor in the reduced labor of not having to maintain instances, monitor instances, provision instances, just a whole range of things, update AMIs, etc. Sorry, yeah, you were going to say?
Yeah. I mean, I agree with you. Like, we've been using Fargate for some of the simpler stuff.
Yep.
But for the bigger stuff, I found it more cost effective to roll like spot instances.
Yep.
And
And then
right. Run the containers on top of that.
Absolutely. So if you're able to use Spot, then there's a profound cost savings that go into that. And Spot's gotten way easier to use, or maybe more reliable is a better term for it than it used to be when they would terminate. But yes, so it depends on what the application is. I've been happy with Fargate, and the reason why I say that is I'm being conveyed into the Kubernetes world. And when you go for a year of not maintaining servers, there's another end of the spectrum, and that's that world. So
how does it compare to the EKS?
so I like EKS because I want to run as little as possible. So well, I haven't looked at cost. I have to admit, EKS isn't cheap. It's like 20 cents an hour or something on that line for the management plane. That's not even including the workers. So EKS is going to be more expensive than Fargate, definitely. Actually, I don't know. I'm assuming that will be because you got that management plane and the workers as well. Now, yesterday or this morning, they announced worker nodes in provisioning of worker nodes, management of worker nodes. So, meaning that I use the term serverless somewhat cavalierly, but if somebody else is maintaining it, it's serverless to me. I'm happy with that. Here's my code, you go run it, type stuff. I like that. So I'm a fan of EKS because I don't necessarily like provisioning and installing and updating Kubernetes every 3 months or whatever the interval is, and don't miss an update type thing. So
it's not easy. Kubernetes maintenance is not easy.
yes, I've got a number of friends that are using it, and then I've gone a year with Fargate, and I'd rather be working on business logic than I would.
We use OpenShift, and even the
Yes.
OpenShift upgrades, on-prem OpenShift, and it is supposed to be very seamless, but what we found out is it's painful.
Upgrades
are painful.
It is surprising how much work goes into Kubernetes. So anyway, it's another subject entirely. But I just want to point out Fargate CLI. If you never use it and you do things like I do regularly, and that is I just want to run a task and I don't want to provision instance to do. I just want to run a Fargate. I just want to run a Docker container. Fargate CLI does a really good job of it. But where I've had trouble is it does a really good job in your default VPC that's already provisioned with an internet gateway. So I have my main account, I have done something to it so I can't run this freaking task anymore, and I want to debug to try and figure out what it is that I've messed up in it. The Fargate CLI may be a way to run a quick task. All you gotta have is Docker file and directory, and man, it does everything for you. I particularly like that. So let's go a little bit further. Oh, well, I even said what it was. So it seems like EKS CTL or something else I've used recently does that same thing. I can't think of what it is that looks to see if there's a Docker file in your directory. Hey, great, I'm going to make a Docker image for you and push it and run that thing. And I can't think what it is that does it, but I just ran across it again the other day. It just seems to be a popular thing nowadays. That default VPC and ready to go stuff is a convenience. But I tend not to like to use defaults like that because they become a crutch, where when you try to use them in a non-default situation, all your stuff breaks at that point. So I usually like to go right from the start, make a VPC, do everything necessary and run this thing in it, and then blow it all away, as opposed to using that default crutch. So the lessons learned that I picked up just in my own experience are these guys. Anytime you call something external, definitely treat that as a subsegment, because it's useful to have those for comparison purposes and just raw awareness at any moment in time. Anything that's compute bound, instrument that, because it's helpful to know something's changed. So I use a dependent compute package that I said earlier, in some cases, run 17 minutes worth of really hard compute. It is doing a lot of work, and that's all it's doing, and it's useful for me to be able to compare when they make a change if there's been a noticeable performance difference. It was actually the second case I mentioned earlier where I saw value right away, that their initialization function they had in this package I was using was really slow. And I pointed out and said, yeah, it's funny that the initialization is taking longer to compute. And they took a look at it and realized that they could have made the pandas or something. I forget what it was now. It was actually time. It was telling pandas this was a time column or something like that. Anyway, but they made that efficiency change. And it made a significant difference in the time that it took to run that function. And were it not for that, it would not have been easy to know what the reason for the slowdown was, or why something was running so slowly. Name segments and subsegments. That's what I was saying earlier, is assume that other people are going to be using XRay, other applications, other environments, other projects. All that is going to end up in one system map page unless you've got nice little filters sitting in there. It would be pretty visually confusing to hunt around and find something useful. So think about those names in advance. What does it make sense to have your naming convention be? Dev QA prod, or Dev cluster 1, cluster 2, cluster 3, or cluster 1 service A, or et cetera. All those things together are useful naming conventions to start right from the beginning, because you'll end up with some real clutter is sitting in there with multiple parallel environments. That was the experience I had. This guy right here, sampling level. So XRay can record every single trace that occurs, or it can record some number of them, or capture some number of them per minute or second, or whatever it is. That's where you can do cost savings control. You probably don't need to record every single trace that's going, or maybe you do, but if you don't need to, don't record all of them, because your costs will start creeping up. You can dial that sampling level up, and that's how you control this, so that you can have it be sampling less frequently when you don't need it, and dial it up some when you do need it. So, and it may be you need it high all the time, but that's where costs will start to creep up on you, I found. Or I assume, like I said, one day I went to 6 cents. So, think about the metadata that you want: the request ID, file name, cluster name, user ID, or whatever it is, any of those things, and include those as metadata or annotations, depending on what they are, early on in it. What do you think should be a segment? When a container starts, or when it starts processing a request. Or if you're blocked on an SQS queue and you're waiting for a message to come in, is the segment when you start processing a request or when you block on the queue? So for example, I use FIFOs with long poles in them, and if I start a segment at the container start, I actually see the long pole intervals in each of the traces. It's an interesting thing to look at, but I don't think it's the right way to do it, and I don't have a good handle yet on what that is. What is the right way? Lastly, here's a lesson learned. So in REST interfaces, you probably don't need to instrument your health check. Maybe you do, but you probably don't. That health check's occurring at a fair interval that's occurring. And again, that's capturing data that you're paying for eventually once it goes past some number of them. In that sampling rules file, what this guy I was talking about right here, the sampling level, you can tell it, don't capture data for this REST path, which is my health check. So that's just a useful tidbit to be aware of. So has anybody else had anything in here that they want to pass along about XRay experiences, or good or bad, or just observations, or things I've left out entirely? But I know that some of you are at least using it to some degree.
I was curious, what does it look like if you try to throw it at infrastructure that isn't like pure AWS? It seems like it works magical, between Fargate environments and SQS queues.
Right.
But like we send a lot of data through RabbitMQ. So if I want to trace a message that comes out of one application, goes through RabbitMQ, ends up in another application, what does my path look like?
So I think that the end-to-end tracing, again, for resources outside AWS, you're having to capture that. Either it's not going to know within Rabbit itself, but it's going to know your message to Rabbit. And I've never done it, but that metadata you can add to it will convey that request chain to it. So if you look at the headers that are in the request when you first get it, there will be an XRay header sitting in there, and I can't think of what it's called, but it'll be apparent. that's what you would add to the metadata being sent on down the request chain. And it would let it come, when it comes out the other end, it would be able to associate the two together. So I think what you would see is it enter rabbit, and then the response coming out the other side, or when you pull it from the other side. I believe that you would see that as one segment.
But I probably wouldn't see the time spent in rabbit in the middle.
Only
other
the
than
start
this
and
gap.
finish.
Right.
You'd only see the start and finish, not what's going on inside it,
Right.
unless you change the rabbit. Well, you're probably not changing rabbit code, but if you were running your own rabbit and you could add metrics inside, you could do it, but you probably would not. That would be my guess. So no, it would not have any visibility inside a resource like that. So yes, that's a good point. When I said that you can do stuff outside AWS, what I was really saying is that you can capture segment data outside of it, but you're having to put those metrics in yourself to say start segment, end segment.
Got it.
Yeah, interesting question.
You said it is going to be cost effective, right? And if you have a lot of traces, and where are all those traces going to be stored? In S3, or will you have to pay for it?
They're in XRay's service itself, and I haven't had to go back more than a few days or a couple of weeks previously, and I don't know what the time frame is actually. That's an interesting question. I think I did know it at one time, but I don't know how long the trace data is actually sitting there. It's not evident to you outside, meaning you don't see it in a bucket somewhere, for example. I would imagine that's where it's being kept, and not as a part of your service.
Can you control the time length of the traces to keep?
I never have had to. Good question. I don't know. I don't think so. That's a very good question. Now that you said that, I have not thought about that. I do not know, but I will look now that you said it, because it'd be useful to if you were collecting a lot and you wanted to keep them down to a day's worth or something. So I don't know. Yep.
I don't know if you have experience with that, but do you know how this compares to other tracing products? So, for example, we used to use Datadog in my past company to do similar stuff.
Yep.
So I don't know.
So I'm going to be more familiar with AppDynamics, for example, and these are things that are serious. The licensed tools are going to be pretty serious, and they're going to instrument JVM or
OpenNet is one
out to yin yang.
from
So.
OpenNet from Riverbed.
Yep, offset, yeah,
OpenNet.
right,
We've used that extensively. It's
So-
very good.
So comparison-wise, this is going to be much cheaper and easier. It's probably not going to be at the level that you're talking about with there. I mean, with AppDynamics, you could get some serious tracing going on side of things. So it depends on the level that you're using it and how much you're willing to spend on those sort of licensed tools. And one of the things about licensed tools, this is what I've observed in one of my previous engagements, was that they use Splunk in production, they use anywhere else. Well, what that meant is the developers never got used to using Splunk. They didn't know how to use Splunk. They didn't create dashboards. They didn't tune their code to more optimally use Splunk. So you would see it used in a really inefficient way. You see their logging look very inefficient in prod, whereas if they were using it as a part of development, it would have probably conveyed more easier. And that comes back to that issue. And that when I said, why aren't you using it in development? Well, it's too expensive. They don't want to use it. So I think that the tools that are available, if you could budget them to be in all the situations where they might be useful, you'll get benefits from them. If you're only using them in a production environment, you'll probably get less use. But the serious tools definitely are going to have more capability than this. I'm pretty confident in saying that.
And my other question was, how easy did you find integrating the XRay SDK into your Flask apps?
That was the same thing as the Lambda. I mean, literally, it was nothing other than the import. The difference between Lambda and Flask is going to be minimal. Where I did find it confusing in one case was the annotations. I thought there was an annotation that I don't think I was using right, but it's that idea of annotating a route and having it do everything below it itself. Well, it worked out really well. I did not find it difficult at all. But that being said, with Fargate, that's on my lessons learned. It's not. So here's one of the lessons learned in my Fargate application, and that has got a task definition with the main app container in it. You had to also include the XRay agent as another container in the task. That was one of the aspects that were different of it. So there had to be something to act as an aggregator and forwarder, and that's what the XRay agent was. So all of my Fargate tasks have that sitting alongside of them, and that's actually one of the issues I had with the Fargate CLI, was that there wasn't a way to add a second container.
So is it a sidecar? Like a sidecar?
The equivalent of a sidecar in Fargate. But what I did was this, because you can run the XRay agent What I did was in my Docker file, and it should be in the example repo, I install the agent in the container itself. So I mean, you can have a container can do more than just run the application if you want. So in the container, the Fargate container in the task, I have it run the app and the XRay daemon or agent inside that one container. But the only reason I did that was I was using the Fargate CLI. There wasn't a way with Fargate CLI to say run 2 containers in this task. It would only run 1 container. So anyway, I know I kind of jumped around on that. The main thing to be aware of is that there has to be an agent somewhere. So on an EC2 instance, you've got an agent on the instance that's probably connecting and or aggregating and forwarding all the data. In a container, it needs to have it available somewhere as well. So with Fargate task definitions, you can have 2 containers, 1 app and 1 agent or more. And the Fargate CLI was 1 container with the agent running inside of it as well. So in fact, the fun thing to do in that was the Fargate task entry point for this demo was a script that started the XRay agent in the background and then ran the Flask app in the foreground. So, and that worked perfectly. I had no complaints, and that's where some of those screenshots came from.
Maybe worth noting too is that XRay may not be for everybody.
Yep.
It depends on where you are relative to being what I call AWS native, right?
Yep.
If you're not AWS native and all you've done is like ported your RabbitMQ, your Redis, your Elasticsearch, and you're running all those things yourself, right? There's a lot of heavy lifting to get the data into XRay, right? Whereas if you bring in something like New Relic, Dynamic, Dynatrace, etc., right?
Yep.
It's an agent that runs the machines, right, and it just keeps track of whatever is running in these two instances, right? And just collates all that information together, right? So it may be a better path for you if you're in that sort of mode, right?
Yep.
Where you're just running everything. There's other scenarios where if you have services like us in Resonate where we receive anywhere between 700,000 and 1.2 million requests per minute, right? It's a lot of data to pipe into a service like XRay, right? It may not be the appropriate tool for you to use this kind of service, right? So think about your use case, right, and what you've done today, and
Okay. That's the main thing, absolutely. It depends on the situation, obviously. So that's key. In my case, it's worked out extremely well, and definitely been that useful idea of saving on labor. But in high traffic environments, that may not be the case at all.
Looks like it stores data trace for last 30 days.
Is it 30 days? I wasn't sure how long it was. That's funny.
30 days, but it does not say if you can store beyond 30 days.
I don't think that they're, I don't think I've seen, I've
yeah.
only used the default, so it's interesting that I've never needed to go beyond that time, so that's an interesting point. I know you can export the data. It is possible using the XRay API to get the data and then put it somewhere else. You can make it available outside. All right, and then some of the things that I want to say here. The presentation, by the way, is this guy right here. What that says is github.com/presentation-AWS-XRay. So what I was trying to do with this before this presentation, I gave this similar or almost same presentation at the AWS DC meetup, is I wanted to use the CDK to provision that app, and I could not get that freaking thing to work, save my life. I had a problem with Internet Gateway, and it just blew my environment up, and I never got back to it. The other links are how to find stuff about XRay pricing on it, the developer guide, which is a good thing to look at, and definitely associated with it. The Flask SDK for it. The Fargate CLI, again, which is real useful for one-off type things where you're doing stuff, I've found. Interesting read on Fargate. And lastly on Flask. So what other questions or comments do you have? Or anything you want to say about it, or any just your XRay experience, or Fargate, or not Fargate for that matter?
Could you just give us a minute on yourself, who you are, what kind of projects you work on?
I have been
favorite,
around
least
a
favorite
long
parts of
time.
AWS.
I've been in software and defense for a long time, and then in the dot-com boom, I waited 2 years too late and went into the commercial world, and which is why I'm still here, as opposed to living on an island I bought somewhere. I worked for large companies and small companies. I did consulting for 5 years or so. That was an interesting experience. It's the first time I'd done a consulting type situation. So I tended to find that to be one of the more challenging things, because you always had to be ahead of the client. And you would bounce around some. But one of the things I did find about consulting that I'd never experienced was you were a hired gun. You weren't really part of the team. You were there to do specific things, but you weren't really there. Whereas, as previously, one of the things I've always liked, and this is one of the benefits of having been around the block a long time, is when you see something from inception all the way to being in the field, and you see the outcome of your decisions, and that is a useful, that can be a rewarding thing. It is a very good learning experience to see a decision you made 6 months ago. How well did that really work in the real world architecturally, and did it not work as well as you'd like, or did it work really well? So again, I worked in defense for quite a while, in the commercial world for the rest of that while, and it is fascinating to see technology evolve over time. You know, as I said, I've seen a lot of technology evolve from when I used to use the PDP-11 and RSX 11M, and I've used VI for very likely longer than some of y'all been alive.
I still think it's powerful.
Yeah.
Yes, I have no complaints. I'm pretty good at it, so I have a bent towards VI for some reason. It's just funny how I still use it in Python, so, and I don't even realize it sometimes before I do that. So that, I mean, that in a nutshell, that's just me, nothing special.
Cool. Thank you.
Yeah.
All right.
All right.
Thank you, Doug.
Sure, I hope like I said, I'm spending more time with the CDK, and I'm trying to get better at it, but I'm still not as good as I am in CloudFormation. I swear I can copy and paste from old CloudFormation templates to new one and do something faster than I can do something with CDK sometimes. And it's just a function of time on the keyboard, I'm sure. But
That's always the next time.
yes. Actually, what I intended to do, I mean, I offered you this presentation. What I'm working on another presentation I'm really doing is EventBridge. And I've gotten to be a big fan of EventBridge, but I've been distracted by Step and Lambda stuff lately. So anyway, that would be it for me. I hope this was informative, useful, or whatever, and hopefully Kirk can get here and talk about Jupyter next time, because Jupyter is a really interesting thing if you do Python stuff. Definitely.
Thank you.
Thank you.
All right, thank you.
Thank you.
So with that, Brent is going to show the third presentation.
Oh, I'm sorry. I didn't realize there was another one. I was.
Oh, you're fine.
I
You're
was
fine.
jawboning. All right, do you want me to unshare?
Yeah, if you could.
Absolutely. Sorry about that.
Okay.
You filled up for cake, so you're okay.
You should have yelled at me. Oh, parameter store. I'm a big believer in that.
Hey everyone, just to give a little bit of my background, my name is Brent Driskill. I'm one of the DevOps engineers here at Resonate, and what I want to talk about is parameter store. So we are slowly migrating to parameter store, and so I want to talk about our problems that we've run into, and then also like the solutions we've come up with for those problems. And we are pretty much 100% in Docker. We use Fargate for some stuff, but we're mostly running basically running containers within ECS on EC2 instances. So, just to give a little bit of background, how many of y'all in here have used parameter store?
Big one.
Awesome. So, basically what parameter store is AWS's answer for basically key value store for configuration and secrets. Kind of the big benefits of it is it's serverless. There's absolutely no management involved. It's as simple as like you can just go in the UI, go to parameter store and just plug in, put in your key and then a value, and you can encrypt it with KMS if you want. And it makes it really easy to separate your configuration from your code, which is what we're going to talk about. And it is super cheap, as in pretty much free to use, which has been like the big benefit for us. Is like, one, you don't need anyone to manage something. So past experience, we've been using Console to manage all of our configurations. Console has a pretty large management overhead, plus like all the work that goes into getting your configurations in there, etc. While parameter store is very simple. And yep. And then I just wanted to mention ECS. I assume most of you all in here have touched ECS a little bit. If you haven't, it is AWS's Docker solution. Basically, it's container orchestration. There's two different types. There's Fargate and there's Fargate and then EC2. So Fargate is you're running it serverless. EC2 is you're running it on your own EC2 instances that you've provisioned. Just some quick terminology. There's clusters in ECS, which is a grouping of one or more container instances. There's task definitions, which is basically describes a set of containers. I always think of it as like AWS's Docker Compose. And then services are a set of one or more tasks defined by a task definition. So anyways, the big thing I want to bring up here and why I want to talk about parameter store in this is there's a kind of a Docker law out there that you should never embed your configuration or secrets within your Docker image. You should always have your configuration separate. Basically, your Docker image should be kind of dumb, and it should come up and basically externally receive all of the configuration it's supposed to have that it needs to run. So either get those through environment variables or be able to call out to some external service to obtain its configuration. So here is where we've started to run. So parameter store is super easy. You go into the UI, and let me just show you real quick, just while I'm talking about it.
While Brent, gets to the parameter store, right? That Docker log, can also be found when you think about 12-factor applications, right? Externalization configuration, right? That's a key aspect about 12-factor applications.
Yeah, so this is parameter store up here, just an example of it. It's as simple as go to create a parameter. You can give it some type of name, like this is like, we'll just call it name, and then you give it a value. So name Brent, something like that. If you want to secure it, it's as simple as clicking secure string. You can use, so parameter store by default provides its own AWS managed KMS key. You can use that, and that's what it uses by default. Otherwise, you can create your own AWS managed customer key, and then use that there. And I honestly super recommend that if you're going to use parameter store, because you can create your own customer managed key, and then set up specific users that can use that key versus other ones that can't. So you can basically lock it down where, like, hey, only a certain group of people actually can put secrets in parameter store, and then anyone else who tries to read from it won't be able to read those values. So it's basically how you can separate like secrets that maybe your DevOps team needs to know that the developers do not. But the developers may want to go on parameter store and change other values.
Is that the only way to differentiate it, or?
So there are other ways. I mean, you can use with IAM roles. You can also set it up so that you like lock down on specific parameters. That's kind of like how you can block like even parameters that aren't secret. But personally, I think it's easier to just have a KMS key that maybe only your DevOps team has access to, and then you can lock it down that way. But there are other options.
Now, what about namespacing? Is there?
Yes, you can. So in AWS, the namespacing for parameter store is a little tricky. What I'm going to talk about with the slashing and stuff is not necessarily a standard. It's kind of something that people have adopted, and AWS is kind of catching up now.
But roll your own namespace?
Yeah, so basically, if you want to lock down something in IAM roles or some other way, you have to provide the full path. And that's kind of one of the challenges we run into is you have to provide the full path in your IAM roles, and you got to provide the full path if you attach any CloudWatch events to parameter store. So parameter store does support CloudWatch events. You can set it up and say, hey, if this parameter changes, set off an event. If a parameter is created, set off an event. If it's deleted, set off an event. It's pretty cool, but you can't namespace it.
There's no like wildcard.
There's no wildcarding. Actually, just what they announced at re:Event just a couple days ago was actual wildcarding for search in here. So it used to be like just a week ago, if I had something like this /config/dev/test service, I couldn't search for just test-service, but now I can. So they're catching up, but it's not quite all there yet. So anyways, if you go and do your research right now and you say, hey, how can I have a Docker container, and I have put all of my configuration into parameter store, or I even want to put my configuration into parameter store, and I want my developers to be able to do it easily, the existing solutions, which I'm going to talk through, they're not all that great. But they're out there, and we're going to talk through them. So the first way is AWS's way that they tell you to do it. So basically, in your task definition, when that you create for your container, there's a secret section in it. Inside that secret section, you put a name, which is going to be your environment variable that is within the container when it starts, and you put value from, and you give the full path to the parameter. Now the big challenge that comes in here, which we were just talking about, is if let's say you have an app and it has like 200 configuration values, you've now got this huge list of 200 parameters within your task definition, and you've got to call out every single one. Personally, I find that to be a pain, but this is AWS's way of doing it, and it's really simple. So like, if you're gonna run, just my recommendation, if you're gonna run a Fargate task, and you probably have maybe 2 configuration and values and parameter store, run with this. It's great. But if your configuration grows or changes or modifies a lot, or you have a large amount of configuration, we need to talk about some of the other solutions. So one of the other solutions out there right now is ConfD. It's an open source tool. I put the link to it. Basically, it utilizes file templating. So ConfD is great, but it's complicated. It's kind of like learning a whole new language. So basically, it works off of Golang text format. I think it's similar to Jinja. I don't know how many of y'all have used Jinja before, but Jinja is like what lies underneath if you used Ansible. But basically, you provide a configuration file, and you provide some templated file, which could be a YAML with curly brackets in it, and basically put what the key is for parameter store. And then you call confd on that template, and it'll read from parameter store and write into it. So you could basically have like YAMLs or JSON files with a whole bunch of templating in them with all the parameters in parameter store to use. But the challenges with this are, basically you've got to build into your Docker images, basically your templates and your configuration files in order to, pull the values from parameter store. It just adds a lot of complexity. But this is a solution that a lot of people are using if you read up on it. The next one is a tool called Chamber. It's from Segment.io. They have a lot of cool stuff, actually. But this one is built just for parameter store. So the thing I was going to mention about ConfD does not just work with parameter store. It works with a whole bunch of other technologies. Console is one of them I mentioned earlier that it works with. It also works with pulling from like just straight, I think, JSON files from S3 and stuff like that. Chamber is another tool. This one's actually pretty cool. But basically it provides the ability to read and write to parameter store, plus just simply saying, hey, it wraps parameter store, kind of takes all the complexity away of having to namespace everything. It allows you to just give a service, and you could read and write like individual values for that service to parameter store. However, it requires, so basically to get, let's say you boot up your container, want to get configuration, you're going to have to write some custom Docker entry point to actually handle Chamber to get all your configuration in the environment. And our big deal breaker here at Resonate was there's no YAML support. We use YAML for almost everything. It's just kind of like something we've adopted. So when you don't support YAML, it's kind of like a deal breaker. They're very JSON focused or something else, I think. But it is definitely a tool to check out, and if you go and read up on it, you'll see a lot of companies have adopted this. The fourth way working with parameter store is third-party libraries. Basically, there are third-party libraries out there that integrate directly with your application inside the code that can read straight from parameter store. I know SpringBoot has one. We have found, and part of the reason we aren't using them here is you now have to update your apps, every single one of your apps, to have the complexity to read from parameter store, and you got to create the classes and everything else built around that. So what I'm going to talk about is, so those are like the 4 current solutions. What we ended up doing, and I'm going to demo it in a second, there is a tool out there that this guy created called AWS SSM Commander. It's a pretty simple Python library that wraps parameter store, or wraps Bodo, to basically allow you to take YAML files and read or write. You basically take YAML files, write them to parameter store, and then read in YAML format from parameter store, and handle all the secrets management within it. This tool though has like almost no support. I think there was like 2 people working on it. So we pulled it in. We're actually planning to eventually re-open source it, but we're currently working on it internally, and this is what we're kind of rolling with. So I just want to demo real quick what this looks like. So we're calling it Resonate PS Commander right now. I want to call it AWS PS Commander eventually. But basically what it allows you to do is, so for example, if I, let me,
Brent, you can show us maybe a little bit more
oh
of the screen.
yeah, clear. Maybe I can zoom in some too. Nope, that did not do it. So let's say I open some, I create some YAML file. So let's just create a simple YAML like app, name, my cool app. Let's say there's some DB, and my username is, I don't know, username for this DB is Brent. It's not a great username. So this is like a little simple YAML. So what Resonate PS Commander can do is, how it works is, you do write.
Can you zoom in?
Yeah, I wasn't real sure. Do you know how to do it? Yeah, see when I was doing that.
It scrolls off the screen.
Yeah. Does anyone know how to zoom in on a
view
terminal?
panel on the top?
What?
From the view panel on the top?
Oh yeah, that might work.
Which the font? I think you just change the font size.
There you go.
There we go. Awesome. Is that working better? A little bit? So what you can do is, so how I built this tool is that we've broken up everything into environments. So you say write, and then you give an environment. So I'm going to say this is my dev environment. You give a service name. So we break everything up because we are pretty focused on microservices. So we have a whole bunch of different service names. So we break up the configuration that way. So I'm going to say this is like my service, and then I give it the YAML I just created. And so what it does is now, if I want to dump back out, sorry, can't spell apparently. You can see that this YAML file has now been stored up in parameter store. And then what we do is, so that we have this simple one. Then what we do is, when we want to start a container, or like for our containers, what we do is, in our Docker entry point, we simply put, so we just add this --env here. It dumps out the configuration now, not in YAML, but in environment variables. Then you can simply just, I don't know why that didn't work. You can do this. Like that. And then you can just do an export config. And then if you do env, you'll now see that your config is in your environment variables, and you can just start your app at that point. So it's really simple entry point. And then if you want to look and see what this looks like actually in parameter store, let's refresh. You'll see that basically how it works is it writes /config and then slashes down the different levels. And then last but not least, let's say I want to do.
So it doesn't serialize the YAML. It parses the YAML and breaks it up into different parameters.
And then pushes it to parameter store and then handles. It's kind of a wrapper for YAML for this. And then let's say I want to set a value, but I want to set something that's super secretive. So this will be my password, and it's super secret. And then you can encrypt it. And now when I dump the config, you'll see that this is KMS, and it gives you the ciphertext. So it's in YAML, but has the ciphertext. And then if you're actually a user of this app and have, which my user does, then you can just do a --decrypt and actually get the password out. So this is kind of what we've been playing with internally to simplify parameter store. This is the thing. So parameter store is great. Highly recommend using it. But the tools are not all there yet to make everything, your life simple. But getting there.
So how does AWS expect one to use the parameter store? They put it out there, but how are they expecting the customers
It's
to
a good question.
Well, I can tell you how I've used it. I used it quite a bit previously. And what I did was, instead of using environment variables for that matter, everything was going to the parameter store. And an example was if you create RDS endpoints or things like that,
Okay.
we actually did it by environment. So what I had with the parameter store hierarchy was the environment name slash the service slash database slash endpoint or something like that. I mean, those sorts of things. So parameter store was really good for acting as a single point that worked across the account for key value pairs and everything that you wanted to keep hierarchically. We did have a lesson learned on this, and this caught me by surprise. It was one of those things where it was a Friday freaking night. The parameter store can be rate limited.
Yep.
And CloudFormation, I had a CloudFormation stack that created a fair amount of resources, and CloudFormation itself can push to parameter store and it can pull from parameter store. So I was doing a lot of CloudFormation activity in the creation of this environment and started getting some errors, and those errors were rate limiting. Now what was interesting was you can't control the rate limit, and it would start throttling it and you start getting errors back, and that was unexpected, and it caused some of my CloudFormation to break for a while. They have since changed it, but originally it was not a configurable value. You couldn't ask them to make it any faster. So in fact, what I had some artificial delays in CloudFormation to keep from hammering the parameter store, because when it gets hammered and you start getting throttled, you start getting errors unexpectedly back, and that was a pain. So, but I think the throttle levels have changed since then. So anyway, that was my one negative experience with parameter store was that. Other than that, I used it quite a bit and I had no complaints about it.
Yes, you have to think of it, there's a key value based database right, that has some integration with some encryption service out there. And AWS sells it as your database for configuration key value numbers essentially. From then on, I think it's still a young service relative to others, right? And so I think you'll see easier out of the box integrations to
Yeah, because for enterprise apps and other things, we use something like CyberArk or something to put the passwords and other things. But I mean, that concerns me.
There is one case here which is not handled in the use cases, which is the password rotation.
Yep.
Correct.
The secrets manager works well with that.
Yeah. The problem with Secrets Manager is it's cost. It has a pretty high cost to it, actually.
It surprised me it's as high as it is, and I wouldn't have expected that. There must be more infrastructure behind it than we realize.
So when you do dump, it just does all this calls, like it creates like four parameters and it calls like 4 times?
So good question. I believe, I have to go look at my code again, but when it's calling parameter store, I believe we're doing a full, we were starting at a certain path and then we're having to call the parameter for every single one. So yeah, I think you're right. So yeah, the rate limiting is definitely a worry.
What if you just save in one parameter because you are working on your side anyway? Like you will have.
Oh, you're saying like, could I store the whole entire thing inside one parameter? So potentially, but AWS does have limits on that. They only allow up to 4K, I think, something like that. So it becomes a problem if you have a large configuration.
But it's entirely possible for you to have some value that's JSON. But then something after the fact needs to be able to handle that JSON more gracefully, as opposed to just a plain key value, right? Where the value itself is useful. Up to you, right? But we rather have granularity on the key value so we can control its life cycle independent of the rest.
Any other questions? Yep.
General configuration lists. If you have configuration by that.
Yeah, so the lists are supported in YAML. And
Okay.
here, yeah.
Cool.
I have a question.
Yeah.
So you showed how we could export in environment variable format.
Yeah.
Do we expect that to be the primary way that parameters in general get communicated into applications? Or
yeah,
is there,
that's
is there
kind of
a-
been what the discussion is.
Okay.
Because the other way to go is what I talked about with, you can just build it into your app. But, I mean, so at Resonate, we're mostly using Spring Boot. And Spring Boot accepts environment variables as configuration pretty simply. So this kind of was the route that we were going.
That's a good question. So environment variables are kind of the common denominator for anything, right?
Yeah.
So any process for all intents and purposes, right? Versus anything else, right? YAML, well, that's something, you know, it's gonna need to read YAML, right? You know, Java key value format, right? Well, that's something that's gonna have to read, you know, that, right? Environment, system environment variables happen to be the common denominator, and that's why we.
Is there any Amazon magic available that, like, just by virtue of running an application in an EC2 container, that parameter store gets automatically communicated into the container?
Only with the secrets thing through the task stuff.
Okay.
Yep.
So there's no dynamic change that can be executed.
Very good question. So what happens, Brent, when, key value pair is wrong, we need to change it, like, how does that process work?
So to restart the container.
You have to restart the container. Yep.
That's where the secrets manager, that's where some of that value comes in, the expenses there, but having it be background that you don't have to worry about it is,
Yeah, that's
it's
true.
again that labor trade-off, is trying to figure out where the value is, or the, compared to the cost. Yep.
Any other questions? So, thank you all.
Thank you.
So with that, I think we are coming to the conclusion, and this is our first meetup. I appreciate if we can all rate how it is, and I think we are going to conduct more meetups in the future. And so take swags from Resonate and read about it. We have a lot of opportunities here, and if you want to, or if you have anyone, you can refer the